Welcome to the last of our series of examples of solving systems of differential equations. Today we're going to take a look at a system that has no solution. We have yet to see that. So let's take a look and see what happens. All right, so what I'm going to do actually is I'm going to take our familiar old system and I'm going to modify it a little bit. Here we have the homogeneous case, but we already know that has an infinite number of solutions. So what I'm going to do is I'm actually just going to change this a little bit and just change it slightly from the homogeneous case. And I'm actually going to keep this as a 0. And I'm going to put a 1 here. And let's see what happens here. I claim that this has no solutions, just making that little change. So as usual, we're going to convert this to our system, rather our matrix of coefficients, which are the same as we've done before. The only thing that's going to change is the numbers we keep on the right side of this dotted line. So everything else is going to stay the same. This is sort of illustrates a key property, so let's keep that. Okay, now over here I have 0, 1, 0. And I can use the method of Gaussian elimination to solve this guy. And it's exactly the same process we've seen in our past two examples, because we know that these numbers here aren't changing. It's only the numbers on the right-hand side that change. So the row operations that we use are going to be exactly the same ones that we have been using. A little boring perhaps, but it illustrates the point. So I'm going to take minus 1 times this row here and add it to the third row to create a new third row. And just like I've been doing before, it's going to be convenient to take this row up here and divide by 3 and then use that to create a new first row. And I'll put the result here. Okay. I'll do this first row operation first as usual. Of course, I've chosen things exactly so that I get a 0 in this position, minus 1 times 3 plus negative 3. Then I have minus 1 times minus 3, positive 3, added to the negative 5 is still negative 2. Minus 1 times this 3, added to this minus 1 is negative 4. And that particular row operation won't do anything to this last position. Minus 1 times this 0 added to that one is still 0. Okay. And then we'll do this final row operation here, just as we've been doing. And we'll keep the second row the same. So, and that stays 1. Okay. Of course, what we do next is take minus 2 times row 1 and then add it to row 2. And we'll see what happens. And that creates a new row 2. And we'll just put the answer there. So nothing is happening to this first row, just like before. Nothing happens to the third row, so we'll keep that the same. And then we'll do this next step. We get a 0 here. Minus 2 times this 1 plus this positive 2 is 0. Minus 2 times this is positive 2, added to that is 1. And then I have a minus 2 times this added to this. It's positive 2. And then minus 2 times this 0 is really nothing. Added to this, it's still 1. Okay, so in the next step, we'll see what happens that causes this to have an empty set for the solution set. And for that, we'll need to go to the next page. So let's do that. Okay, so here we are on a new page. Here I've copied over this matrix, and now we'll do some row operations. I think it makes sense to take 2 times row 2 and add it to row 3 to create a new row 3. And if we do that, what we see is the following. I'll just write the parts that haven't changed. So we're not going to actually change the second row, just the third one. Okay, so minus 2 times, well, the zeros just stay the same. Minus 2 times this 1 added to this 2 gives me a 0 here. Minus 2 times, oh, I'm sorry, it's not minus 2, it's plus 2. Yeah, that's right. Plus 2 times this gives me 4. Added to this negative 4, that gives me a 0 here, just like before. And then I have 2 times this 1. Added to this 0 is a 2. Now, at this point, I can see that I'm going to have 0 solutions for this system. And so just as we've seen in all our other examples, we've got a row of zeros here, except on the other side of the dotted line we have a non-zero number. And that tells me that I've got a problem. And in fact, it tells me immediately that I have no solutions. So here we have, just to review, we have a pivot in this first column, a pivot in the second column, no pivot in the third column. Instead, it's in the fourth column. But the fourth column is special. That's where we keep the numbers on the other side of the equal sign. And if I convert this back into an equation right now, what I see is on the left-hand side I have 0 times x1, not even going to write it, plus 0 times x2, not going to write it, plus 0 times x3, no point in writing that. And then I have the equal sign, that's what the dotted line here means, and then I have 2. Whoa. Well, this is obviously a false fact, so we have no solution.
This is a demonstration of Flip4Mac.
Sometimes we indicate a contradictory statement by either a sad trombone, if we can, or some crossed swords. So we have no solution in this case. The solution set is the empty set. There's a number of ways of writing that. But in any case, this can't happen. So here, the critical fact here is that we came up with a pivot on the rightmost column. And that always results in no solution. And that concludes this example.